Hello, welcome to another episode. This is the final part of our three-part series where we are converting our native Android application written in Kotlin and Jetpack Compose and have it ported to the web using Kotlin Wasm and Compose Multiplatform. In today's video, we will take a look at the following. One, we will change a bit of our app Gradle module structure. The second thing we will do, we will add some web-specific components. The third thing we'll do is we will have the app run on both Android and the web. And then last but not least, we'll look at the different platform differences and how you can will pretty much get around each, because there are some things that would be available on platform A but not on platform B, as discussed in part 1 of this series. So first, let's get on to our Gradle file. Now, in our build.gradle.kts file, which is inside the Compose app module, it seems like we already did our Gradle definitions, so we don't really have to do anything else outside of what we did with Wasm.js block inside our build.gradle.kts in the Compose app module. The next thing we're going to do is we are going to set up some of our web resources. We will start by adding a folder inside the Wasm.js main component. We'll put in a new directory. This directory will be called resources. We will also add the Kotlin directory. These two source sets will be very important for when we are dealing with our web application. Inside our resources folder, we will add our HTML file. You may wonder, why are we adding our HTML file? Since our app needs to run on the browser will only render HTML documents. And that is why we need a HTML file for where our Compose application will be rendered from. Inside resources, let's create a file known as index.html. Fantastic. Now, let's change up the title. I'll call mine Random Recipes. After changing the title of the index page, the next thing we're going to do, we're going to add two scripts. One, skiko.js. This is the file that helps in the rendering of the UI elements on the web. And then number two, we'll have a randomrecipes.js file. This file is the file that will be generated when our Wasm.js module is built. And remember, it has to match the output file name that we did provide in our Webpack configuration. So let's add them. We can add them to the head. There's really no problem with that. So those two files will be handy for when our application loads. Lastly, there's one last thing we must add inside this HTML file. Now, Kotlin Wasm usually uses the canvas-based window to render our UI elements. This means everything that we have on our Compose Multiplatform application will be drawn, measured, and rendered on the JavaScript canvas. Now, if you're a web developer, this might come as a bit of unpleasant news. Reason being, everything drawn on the canvas sometimes tends to feel a bit slower. Secondly, you are unable to do some basic functioning of web components. Things like simply highlighting text and copying is technically impossible within the canvas. That's one thing to note, and it's part of the downsides I will speak about when running Compose Multiplatform using Kotlin Wasm. Now, let's add our canvas element from which our UI elements will be drawn from. For canvas, we'll simply say canvas and then provide it with an ID. So we will need this ID to access the HTML file. We will need this ID when we are running our components from within our Kotlin application. Let's give this an ID that we will remember. I will just call this random recipes canvas. That is it with our HTML file. The next thing, we'll go to our Kotlin package. Within our Kotlin package, we will create our sub package called random recipes that is inside com.rutubishi.random recipes. I like keeping the namespaces the same. However, if you feel like you want to be more specific with, say, for example, a wasm.js source set, you might add an extension for .wasm. So your package name could include the wasm subdirectory. But for me, I like to match them because when importations are happening, they kind of feel like they're being imported from the same app. That's why our Android main had our primary package name as com.rutubishi.random recipes, which is the same case for common main, and it is the same case that I'll maintain with wasm.js main. Some other people on the internet don't usually like this approach, so that's up to you to choose. This is my preference. So let's get on to this. Within wasm.js main in the Kotlin directory, we'll add a new package. So com.rutubishi.random recipes, and we don't really need any other sub package at the front. Next thing, we'll add a Kotlin file, and I will just call this file app.kt. This file, sorry, it will just be called app.kotlin, and it will essentially just contain our application. So the first thing we do is, since we want a composable function, which will be run on the web, we'll just create composable, and then we'll need to give this composable a name. So I'll just call this main, since it will be the main function that is run when the UI runs. Lastly, we'll add the canvas-based window. Okay, so given your app is now known as app.kt, the file name for your wasm.js application, the next thing we'll do is we'll create a main function. This will be the entry point for our JS application. We will need to opt into the experimental Compose UI API. The reason why we are opting into this class is because very many things in Wasm are still in experimental / alpha phase, and some of them are still in development. For now, it is safe to use as of when I was creating this video and the Compose Multiplatform version I am using. So we'll opt into experimental Compose UI API. Something else we will do is we will look for the canvas based window, and this canvas based window does expect a canvas element ID. And this is equal to the name that we gave it here. So random recipes canvas. And then your app is going to go inside that. So we will need to import this. I don't know why my IDE is failing to import it, but let's try to just do it manually. So under x.compose.ui.window canvas based window. Yeah, so for some reason IDE did not want to import this, but that's fine. Now, the last thing that we are required to do is to set up our app inside here. So we'll go into common main and just remind ourselves a little bit as to how the app looks like. So the app just has something like random recipes app, which requires a modifier, and then everything else goes inside. So it is safe to just call random recipes app. So that's what we'll do. Random recipes app will go inside there. So if you have ever worked as a web developer before, you will know that dependencies are usually managed by different package managers. We have npm, we have yarn, we have pnpm, we have ban, and many others. Now with Compose Multiplatform, the default that is used is usually yarn. So we will need to provide a folder for which our yarn lock file will be stored. So the yarn lock file will contain all the information about the JavaScript dependencies that are needed for our project. Remember, our application is about to run on WebAssembly, but on the browser. This means it will need some JS dependencies that will be converted from our Kotlin code. So our Kotlin code will compile into some TypeScript code, and that TypeScript code will now be run on the browser as JavaScript. So let's create that folder. This folder will go to the root of the project, and it will just be called Kotlin JS store, something like that. So let us try to build our Wasm module first. So how do you do that? There is a Gradle task available for this. So if we could just get a look at the tasks available to this project. So if we have a quick run through, there are some few tasks actually we need to run first. So the first thing is we will need to do our yarn setup. And then the next thing that we will do is we will need to run one of these Kotlin browser tasks. So for our case, we will just run the development version, so the Wasm.js browser development run. So before running the Webpack dev server, let's first run our yarn setup. So I'll open a new window, and the name of this task is Kotlin yarn setup. When you try to run Kotlin yarn setup Gradle task, you will get an error. So this error is as follows. It tells you that build was configured to prefer settings repository over project repositories, but repository distributions at this was added by some unknown code. This is because our default project that we created, so when you use the default settings, it sets our repositories mode to fail when project repos are being added. And we may need to change this. So for us, let's just prefer settings. Once you change that, you can try and run your Kotlin yarn setup once more, and it will start to run. So if you don't have some configurations. So before, we're told we could not determine the dependencies, could not find this. So we'll need to tell it where to find the versions. So to find the WebAssembly versions for certain of these tasks, a good number of these tasks, we'll need to add the following line in our dependency resolution management section inside settings.gradle.kts. So we'll add this line if we are using Compose Multiplatform. So let's try to rerun once more. So it still fails. So actually, we were supposed to do repository mode.prefer project. Sorry, not prefer settings. So let's run this one last time. So as you can see, it will start downloading some of those dependencies. Okay, so the build is done. It was successful. Inside the part of the responses that I wanted to show you, I think it's been hidden, but what essentially has happened is it has downloaded node 22, which I did not have, which I believe is the version that some of these things were tested on with Wasm. So let's get on to running it. So for us to run, we will use the Wasm.js browser development run. So this will start a development environment and a server with Webpack through which we can run our app. So let's do the following. Wasm.js browser development run. So we're going to wait for any dependencies to resolve from the JS side and also the Kotlin bits, and then also it will do the conversion of all the things that are on Kotlin to run on Wasm with JS. So, okay, so this did not run, and well, it's for a good reason, because you will notice that inside our common main within our network package in the recipes file, there are some things that are referred to as unresolved references. Well, some of these unresolved references include HTTP, there's a Java package somewhere there, there's a function called call timeout, there's a reference called time unit, and so on and so forth. So this is because when we set up our Ktor API, we used a lot of JVM dependent code. So let's look at it and find out. Go to common main, Kotlin, data, and then go into the network. Now you'll realize that they are all in red. And this means that this actually cannot run because these are JVM specific items. So what can we do about it? Firstly, before anything else, let us comment out this portion and also the HTTP client that we are using. So we just want it to first run and see how it looks. So we'll remove the HTTP engine because that is specific to the JVM. Then we will also comment out these imports. Let's try running this again and see. Okay, so mine does fail, but this is due to my garbage collector limit being exceeded. So we can just try to add a bit of memory that we use during compilation, and we're told that we can add that using the following in our Gradle.properties. So before I change this, it is important to note how much memory you have available. So you will be limited with the amount that you do have. So for myself, I believe I have a good amount to spare, so I will put this all to 4 gigabytes, but I would advise, in the event that you are wanting to increase garbage collection memory, so this will be memory that will be set aside for Gradle to work within your project compilation and build process. So for my case, I think the default is usually something in the region of 2048. A good example is what we have here. So that's 2 gigabytes. And I would say that would be the maximum I'd recommend for anyone on 8 gigabytes of RAM. However, for me, I have a good significant amount beyond this. I have 64, so I can safely add 4 gigabytes as part of my memory for my garbage collection during the Gradle daemon running. So let's rebuild these changes and run once more. Wasm.js browser development run. So my app has run successfully. So you can see Webpack compiled successfully. So let's find out. Now at port 8080, that's where the server is run from. We have this, well, is it good looking? Not really, but it runs on the web. So let's see if full functionality is available. So we'll do something like, what's my nickname? Hello, you, I guess. And if we say, let's go, it will load the recipes, but I cannot see the images. That's an interesting one to think of. If we press refresh, it should load up. So there's some things we can notice from the get-go already. Our loading bar is not looking so good to begin with. Something else, our images just are not showing up. So we'll have to tune that a little bit to get our images to show up. In fact, we can actually, I don't know if we have any logs. Let's see if we have some logs here. So there are no logs currently, but we may need to check on those. But as it is, most of the functionality works. Our app has been able to run on Android, the Android device. We've also been able to run it on the web. Albeit on the web, it's not yet fully complete. It needs some bit of more pizzazz, some magic to work around with. So let's get back to our code and find out what we need to change. Now, our browser Webpack server is running, and it's supposed to watch the changes that we make and auto reload, which I don't really like. I feel like it usually consumes a lot of memory when this Gradle task is continually running. And we can even just confirm this using my very nice Linux tool. But today memory is okay, so we should be fine. All right, so Oh, and as much as we'll be fine, I'll just close this server as we make our changes first. So I'll use Control C, of course, for those who are on, whichever platform you use to close your terminal windows, use that button. Now, the first thing we'll need to do is to address the things we commented. So let's go back to Recipe API. Now remember, we commented a bit of platform-specific code. So there's a lot of JVM dependent code. Number one, OK HTTP is heavily JVM dependent, as well as time unit. So time unit is also heavily JVM dependent. So as is call timeout. Even the call timeout function is a JVM dependency. So how do we configure this HTTP client to also have some web functionality? The first thing is we could just call the common HTTP client. So you could call the common HTTP client, which has a common implementation and doesn't really require any platform specifications. However, sometimes you might want to do a bit more things with your engine. So maybe you want to configure it a bit better than how it is configured right now for different platforms as you'd want them. So in my case, I'd want to do that. I'd want to set up the Android configuration with all its JVM dependencies. And then as for the web, we can also look into how that can work. So since Ktor on the web is not as advanced as what we have with Android code, we will have the Wasm client use the default implementation of HTTP client, and then we will also have Android have its own implementation of HTTP client, which will use the OK HTTP dependency. So how do we do this? Now, Compose Multiplatform, in fact, actually, Kotlin Multiplatform offers an intuitive way for which we can use specific portions of our code independent of its platforms. An example would be if there was something that I wanted to use on Android differently, as in our case HTTP client, we can define it differently with how another platform, say iOS or desktop or WebAssembly, will define it. So you'll have an expect function which provides an interface for definition. It's almost like a contract to indicate that I would require a specific entity to have this return type, but with its values implemented independently of the platform. And that's exactly what we're going to do. So what we will do is we'll create an expect function, which will be called client engine. This will return a nullable HTTP client engine. Now, we'll have this red squiggly line to indicate to us that we need to provide the actuals. So I'll use Alt-Enter to create an actual in Wasm.js main. Come back to here and also create an actual in Android main. Now, within our recipes API, we will create a variable. Let's even make this private. This will be equals to our config block. So where our configurations will go. This is actually of type HTTP client config. which will return units. All our configurations will go in here. So the default request, let's go in here, and with that we can now create our client by saying, so our private var recipes client will be equals to, the first thing we want to do is we want to get the client engine, which is nullable, and if we get that with a value, what we will do is we will just say HTTP client. So the block will contain the engine, and the engine is inside our IT param, and then we have the config block. So actually it's called client, not we've given it a name with our AI tool here. Otherwise, if you do not have that, just create a HTTP client and provide the config block, which will be this. So this is how our HTTP client will build, and we can now remove this JVM dependent things. I have those JVM dependencies removed from there. And then the next thing we'll now to read through the actuals, for this file. So with Wasm.js, for now, let us just provide null as the engine. Just for purposes of this tutorial, let's give it as now. There'll be more on HTTP client engines that are available for Wasm, maybe in later dates, but for now, let's just use now. For Android though, we do have some configurations that we can make. So with Android, we can simply do return, we call this OK HTTP engine. Okay, HTTP engine, and I'll be required to provide a config. So we can have OK HTTP config. We could apply, and we could change maybe something like get the config, and we could do our call timeout. So maybe I can add this to be like 5 seconds or something. So port time unit, which is from Android to Java. So you can configure your HTTP client something in that region. So yeah, let me remove this unused import. So now let's try to run our Android app again, just to see. So if we run our Android app, it does run. So everything does render well. Let's go back to the web. Wasm.js browser development run. So our app runs. Let's try to log in again on the web. Hello P. Say let's go. So that does allow us to run it. So HTTP config separately, and this other one on the web that is configured separately as well. Now we will notice that there are no images. So the configuration has happened independently, but we still don't have our images. So let's get to find out how we can add back our images. So our images are supposed to be loaded with coil. So we'll get a look at that. So let's head over back to our code. Now, for the web, the reason why we are not able to view our images is because for Coil to load network images, it needs a networking library. Now, our Coil dependency, as we see it here, is for the image, it's just Coil Compose. For the network, we had Coil on HTTP for the JVM. Now, we will need to include Coil for Ktor network. And this will be equal to, let me just borrow all this here. We'll only change the relevant bits here. So what we will need, instead of coil network HTTP, we will want coil network Ktor 3. So now this should be a dependency that we can add in our Wasm.js main. So we'll do implementation, and then I will just borrow this because this will be named, it's just Ktor network, so .ktor.network. So we'll just do that, and then we'll resync. I'll also close my Webpack server so that our build can first go into play. So wait for that to finish setting up, and then come back. Build has finished correctly, so let's run our browser once more, our browser task. So it does launch on the browser. Let's put in a name, just something random. Let's go, and then there we have our images starting to load. So if we continue scrolling, so the images will continue to load as they go. Pretty much we've now been able to make our app fully run from Android, and it is now working on the web without having to do multiple definitions of each part of the application and so on and so forth. So we've used the same source code that was running on Android, and the exact same functionality is now running on the web. Now you will realize a few things. Number one, default support for navigation buttons don't work. Reason being, for Android, we always have the system navigation buttons, which you can use to go back, maybe open recent applications or go to the home. So the back button in the system navigation tools always allows us to move from one location to another when we are on the Android device. However, on the web, this is not available. Hence, it means, for example, with our current application, if you go to the details page, you don't really have a way of ever going back. And that comes down to the things or the APIs available for the web and those available for Android for such purposes. This is issue number one in my eyes. With such a big disparity in how the browser works and the Android device works, it might come as not a big shock to think I don't really need to port to the web because there's some inconsistencies. But you can always work around such, and that is the beauty of multi-platform. You can keep platform-specific APIs while using common shared APIs. Now, let's look at a few tricks that you can use to go about such. Number one, we are not going to use our browser navigation components because this is done on the canvas. Now you can create wrapper methods around that such that when you're able to interact with the browser components, so for example, the forward and the back button, you're able to navigate with the same. But for us, we are not going to do that. For this specific tutorial, we will just add actual UI components that will give us the freedom to be able to set up our navigation tools and be able to move from this page to one that was previously there. Another thing you will notice from the app is that everything as it is now looks a bit too stretched and the white space is not being used well. And that again is because my browser window is much larger than what my device window offers for me. So we also need to take into consideration that specific limitation. So for the next few minutes, what we're going to do is we're going to, number one, get into consideration of whether we are on a wide screen or not. And number two, once we know whether we're in a wide screen or not, we're able to perform different behaviors based on the platform that we are on. So let's go back to our code. I'll close the browser server. And we will do some few things. Number one is I'll go into my common main, Kotlin, and then UI. So in the random recipes app file, we will create an expect function. This expect function will have some platform dependent properties that we will need to retrieve from each, so either the browser or the Android device, to know whether you're in a widescreen orientation or not. So I will make this expect function a composable one. So we'll just say expect, and this will have a return value. So it won't have any parameters. We'll just say is wide screen, and this will return a boolean. So this will either be true or false. For this, I will create implementations for Wasm, of course, and also an implementation for Android main. Good. So let's start with the Wasm one. I feel like this one is the easiest one to work around with. So with this one, we could just say false. So let's just return true, sorry. So for now, we won't go through how to check for whether you're in a responsive state within our browser window. That will be something we can cover in another part of the series. Not really part of the series, this is the end of the series, but in another video, but in this same playlist. But that's for the future. That's not for now. For now, let's just assume everyone is on their desktop and they're using their browser. So we'll return it as true. For Android, let's also just return it as false. Feel free to use window class sizes library from material if you're using, actually not if you're using material, if you're on a native Android app, that library should just work. So material class sizes library or dependency will allow you to know up to where has the screen reached. Is it in a wide orientation? Is it, you can do all that calculation. That's why I've left it as a composable. So in the final version of the app that you will download, I will have included the implementation of there. So for now, On Android, it just says false for widescreen. On web, it says true for widescreen. The next thing now is we should, in the scenarios and the portions and places that we want to use or we want to cater for this thing being widescreen. So let's start with meal detail. Meal detail has some things I'd like us to consider when we are in a widescreen. Things to consider when we are in a widescreen. So right now, as it is, we have our image. That is the first one, and then the two texts follow beneath it, and this is for it's inside a column. So let us try to do the following. The first thing is in the event we are in a widescreen, I'd want the image to be on the left and then the items to go on the right, so the texts to go on the right of the image, as well as adding at the top an arrow back key to support back navigation when you are in a widescreen. So we can do this by just trying to first let's add, so if is widescreen, we'd want to do something, but if you're not in widescreen, we also want to do something else. So if you're not in widescreen, I'd like you to have properties of this column. Should actually delete this instead of copy. But if you're in widescreen, we'd want something a little bit different. Actually, this will only need it for the content. So let's not put it here. Let's actually put this if there's success. You could still do it for when it's loading. That's up to you. But yeah, for my case, I'll just do it when it is success. So if app resource is success, if you're not in widescreen, you can just have your entities continue in this order. But if you are in widescreen, there's some few things I would want. So the first one is I'd want an icon button, and the icon button has some contents. So it will have an icon. So just import icon from the one that has an image vector. And I do not want this small vat. What I want is I want the two-tone dot, so it's actually auto-mirrored dot two-tone, just in case someone is on a different so we can say arrow back. So that's the first thing that we will do. We'll have that on the top, and then we'll have a row. This row will have things centered vertically. That's okay. Modifier will have modifier padding being 8. Something else we'll want is to give our app, so even the padding being 8, I'd like this to be a bit more. So horizontally, I'll give this to like 100 density pixels because we are on a wide screen. For this also, we'll do our async image inside the row, but for this async image, we'll now have it fill max height and then fill max width, but the ratio should be 0.5 f. So I want to fill half of the width and fill the height of whatever the container will be like. So the row also, I'd like it to fill max height, actually fill max size of whatever is remaining. So icon button at the top, padding horizontal is 100, padding vertical will be, let's say, 8. So there's the sync image there now, with different height and width. And then lastly, we will have our texts show up here. So I'll just copy those and have our text show up there. So this is for if the app is in widescreen. So again, let's try to rerun our browser run. Okay, just some random name. Let's go. So this is the image. Click on that. So now we're kind of close, but not exactly what I'm looking for. I was wanting this button to go maybe to the edge at the end, and then this too can be vertical. So that is quick to change. So we can just do, so this two texts actually, they're supposed to go inside a column. Then for this, I don't know if we did center horizontally, so let's change the alignment for this. Modifier dot align. So alignment dot start. I'd like this to be at the beginning. So do that again. Oops, sorry, ran the wrong one. I want to run the browser server. Successful. I'm gonna do this again. Do that. So it kind of is in the correct place. Also the texts are in the orientation I wanted them, but we still have to make some distinction between the title, the text, and also the space between here. So let's go back to that. We'll also say here in our column, we'll add a modifier as equals to modifier dot padding start. Make it 16 dp, so I'll have my AI use that for me, and then so that will give a bit of a space. The other thing we want to do is we want to give our icon, when it clicks, a chance to navigate back. So for this, we will need our nav controller, and inside here, we will simply say nav controller dot pop backstack. So pop the backstack there so that it takes us back to where we were. Lastly, we'll need to provide this controller to our meal detail. So we will go to here, and then we will provide our nav controller as nav controller. And then also it's important for us to change where it is being used in the test. Change the portion in the test. So this one we will have to either create a mock nav controller, which is what I'd suggest you to do, but for now let's first run. We don't really need to run the test, but let's first run the app just to see whether we get to scroll back then. So it's run successfully. Let me just refresh this. Let's go. Let's probably pick, the first one. Bread omelette says make and enjoy. Press back, takes us back. Smoked hammock shows us that. Can press back. There's also this. Okay, so the details page looks a bit better. Of course, you can always try to style it a bit more depending on your like and what you want. But on the baseline, that technically works. The last things that I will want us to do is number one, for our primary page, let us change the number of items on the grid, the number of columns on the grid, sorry. Reason being, it feels a bit too stretched out. So it feels like the space has been wasted. So let's try and do that. So we will head over to our good old UI for, is this on meals? This is on meals, and then we have some few things. So the first one, of course, is the text, which is okay. There's this staggered grid cells, and they are fixed. So we'll just say if is widescreen. So if you're in widescreen, then we'll use 4. If you are not, you'll use 2. So yeah, that kind of allows us to increase the number. So let's again just close this and rerun. So it's supposed to watch, but for some reason I don't feel like mine does always watch the changes of the files. So that's why I'm keeping on rerunning every time. But yeah, just depends. Maybe if you have a bit more info on why it auto reloads for me, it doesn't auto reload for me, then yeah, you can tell me in the comments. So go back. Let's go, and now it looks a bit better. So if you're in a widescreen, shows us in 4s, which I feel it's a bit better. We can even do 5, I think. But this is a value that you can change depending on how your screen adapts or how your screen changes. So have that in mind. Whatever looks best is just dependent on what you want to achieve. So you built your Android app and you're thinking, I want to expand my customer base. I want to try out how will this thing work on the web. Kotlin Wasm is a good alternative and platform for which you can build your native Android apps and make them run on the web. This will allow us to port all our Compose UI and Kotlin logic into still Compose UI, but with Compose Multiplatform on our Kotlin Wasm environment. Now, there are some advantages to this. You can very quickly set up an application that will run on a different environment without having to rewrite a lot of your code. Number 2, this is a good way to test out products on different environments. In the event, maybe you wanted some more specific implementations that you feel like you'd want to do that are in specific to the platform, then you could always go on and add extra platform specific things. Now, this might not be a good solution for you if, one, you don't like using products that are in alpha stage. So a lot of things on Kotlin Wasm and Compose Multiplatform running on Wasm are still experimental or in alpha stage. So this means there's not a lot of stable APIs that you can use. a good number of them require you tweaking and turning a few things here and there as you move around. If that's not something you'd like to do, tweaking around with build tools, then this might not be a good option for you. Maybe try out a different technology altogether, like Flutter. I feel like it doesn't have too much tinkering, like how this current stage of Kotlin Wasm and Compose Multiplatform is at. Another downside, this project or this type of approach may not be for you if you would like much more interactivity on your browser page. Now, in as much as you can do so many things on Android with regards to things like highlighting and copying, I think that's like the primary one. Actually, I wanted to focus on even the load times for your app. Then Kotlin Wasm and Compose Multiplatform might not be your best friend. And it's because it runs on the canvas. And things that run on the canvas will require some graphics to be drawn and add interactivity. Currently, you're able to do only basic things of like clicking, and native browser components like going back within your URL are not even supported. You may have to write a wrapper around that for you to be able to use that with Compose Multiplatform. Secondly, since everything is drawn on the canvas, it feels a bit sluggish and lazy and might not be good for a production application. Which brings me to my third point of a downside. Kotlin Wasm with Compose Multiplatform Kotlin Wasm is still in alpha, as it is at the time of writing this video. And so many things are bound to change, and it may not be a good use for your production app. So if you're looking to put your Android app on the web in production immediately, I would suggest hold on just a little bit. With that, thank you very much for being with me throughout this entire series. It's been long, but I hope you've learned something, and wishing you well in your journeys with Kotlin Wasm. See you in another video.